like really smart, but they don't get good grades, or raise your hand. Cool. All right, enough shameless plugs. Now we're going to start the meetup. Thanks for being here again. I'm going to introduce John. Come on over, John. Let's give him a round of applause for being here. So John is kind of like the in-house band. He has presented Monday, Tuesday, and now today, Wednesday. So 3 nights in a row he's presenting at our meetups. And John's a good friend of mine. He's building this amazing technology where you can basically program and code in a virtual development environment. So I'm not going to spoil it. He's going to show you how that works. It's all in the JVM. It's all Java code. So and the data engineers in the house who are writing Java, this will be very practical and applicable to you. He's also going to be scaling it out to other languages in the future. I'm going to hand it over to John. And but before we hand it over, John, can you tell us a little bit about your background real quick? And then we'll get started.
Yeah, absolutely. So I am coming from the world of computer-aided design, where you know, for an engineer who's building hardware and you know, really just wants to be able to create things, the prototypes for designs that are then maybe going to get turned into something real. It's really nice to have a version of that model, a virtual version, and computer-aided design software has been this powerful tool for a really long time. There's a natural marriage between CAD and virtual reality, which is the platform that we're developing on. However, we decided to take this in a bit of a different direction. So we're actually focused on applying computer-aided design principles to computer programming, and that's what we're going to show for you guys tonight. We have a live demo. It's going to be really fun. I have been doing this demo for the past 2 days. However, we are going to mix it up tonight. I'm going to show you a little bit more of a complicated program, as I know this is a crowd that enjoys looking at lots of data. So it's going to be a pretty awesome demonstration. We're going to be looking at the Java C compiler, which is a 150,000 line code program. So pretty cool stuff to look at in VR. So I'm really looking forward to show you that tonight.
All right, and I'll be fielding questions. So when we get to the Q&A part, I'll be rolling around the room with leap motion controls. And whoever asks a question, I will bestow a nice leap motion control to you. And let's get started.
Yeah.
And let's give John a round of applause one more time.
And for starters, I have one of these leap motion controllers. It's yours if you want to volunteer right now for the demo. Back.
Right here.
Sir in the back, you were first. Quick reflexes. That's good. Yes, please, come all the way up. What's your name?
Connor.
Connor. Let's welcome Connor, everyone. And in exchange, please follow me this way. I'm going to take you to my virtual room, which only you can see. Here, you're going to put on the headset. Yes, you can. Yes, it should fit. And the best way to do it, actually, just put it on your face first. Strap over. Push it, and it should fit inside. Yeah, there you go. You got it. Awesome. Okay, so Connor's in there, and now we're going to take a look at what he's looking at. Okay, so we use virtual reality to give you a window inside of a computer program. So Connor, I've got 2 other things for you here. I'm going to give you these hand controllers. Go ahead and reach out and grab that one and this one. Switched off. I'll turn it back on. Here's your other one. So cool thing about the platform we're developing on the HTC Vive, it lets you do room scale tracking, means we can walk around inside this environment. You can also use your hands. That lets us actually reach out and really grab onto the data. So Connor, you see in front of you there's a menu. So that's, you can really just put any kind of information up, and in VR, you've got lots of room to display information, so it's really fun to build for this. And then as you found on the floor, there's a very large diagram. And actually, I'm going to ask you to take 2 or 3 steps back, and I'm watching out for you, so you're not going to run into anything. I'll use my hand as a guide. Turn to your right a little bit, and then, so turn right 90 degrees, and then walk this way, backwards. I gotcha. Give you a little tug, a love tug. Okay, that gives us a little bit better view. So what you're looking at right now is a hierarchical diagram of a very large Java program. So I mentioned this is the Java compiler. It's what is commonly used to compile programs into executable Java code. It's got a lot of different parts to it, and what we do is we organize these diagrams by their directories. So as you might group similar pieces of code into a directory just for organizational purposes, what we're doing is we're doing that graphically here. So Connor, as you can see, there's sort of a web diagram here. I'm going to direct your attention to the branch on the left. You see the label that says source? It's right below sun. Great. And then you see there's a couple of other leaves on that branch. There's doc tree, and utility. You see those? Cool. So do me a favor. Let's go ahead and, with your left hand, just as you're doing right now, when you see one of those menus light up, go ahead and there's a trigger underneath on your left hand, and you can pull that down and pop open the directory. So go ahead and lift your arm up and reach it to some height where we can just take a look at this data. Yeah. Say again.
It's amazing.
Not my words. This is always fun with this demo because actually, Connor, I forgot to ask: is this your first VR experience?
It is.
This is Connor's first VR experience. This is very special. We all get to experience it with him. This is like actually one of the best parts of doing this is just showing people VR for the first time. I've done it to a lot of people, so it's I get around. Anyways, Connor, go ahead and take your finger off the trigger. And I'm wondering if I should layer more innuendo into this. I'm going to stop there. Okay, so you see that there's a large directory here that we're looking at. So let's see what we're taking a look at. And I'm going to actually change the contrast here. Don't mind the sudden change.
Oh,
let's
wow.
find one. The other hard thing about this is that we haven't optimized this yet for screen projection, but hopefully, is that not too bright for you in there? Okay. So this is a little bit better contrast. Sorry guys, I was trying to figure out what would work best for this demo. So go ahead and take one or two steps forward. You can get closer to some of those labels. And again, I'm looking out for you, so don't worry, you're safe. We're looking at some classes inside of this directory. So you see in front of you have these objects, class tree, and as you've actually already figured out, you can open it up and look at the source code. So go ahead and scroll up and down on that touchpad that you just pushed down. So, and I can actually skip past a lot of that. There's this is a giant file with a lot of comments. And then you see some actual executable code there. So what we're doing is we're accessing the source code that's inside the class. So a class is just a document or a script that contains some code. It stores data, has methods for actually performing actions. And what we do is in the environment, we map it to an object. And then you pull out this source code so you can read it. And the idea here is that you're using this as an exploration tool to look at, as I said, a lot of code. There's quite a bit going on in this program. Go ahead, so let's see, and the directory that we're inside of right now, can you actually look up towards the ceiling and just so I can get a sense of, did we open util or is that tree? Tree, right? So everything he's looking at here are all the building blocks of what the compiler uses to actually turn your source code into something that executes on the computer. So you see a lot of commonly used, so binary tree, block tree, break tree, these are all alphabetical, so they're just, we're in one section here. You'll see if statements, a bunch of things that go into building a program. But the point here is just to see that, what would otherwise be a very tedious thing to look through, you'd be double-clicking on a lot of folders to get through all this information. We're just giving you it mapped out in a spatial way so that you can actually, your brain can sort of orient itself a little bit. Kind of like, well, really it's like a structural diagram, like, well, we like to think about it like a map of information. So as you see, Connor's happily exploring this code. If he was just learning this code for the first time, he could explore and have a guide like myself actually walk him through this, or just freely explore it. But the really fun thing actually is when we go and execute the code, and that's when you're really going to see some cool stuff. So we're going to go ahead and flip over into that mode. Connor, if you could, just take, actually let me see where you are really quick. Go ahead and take one or two steps back. I just want to follow along with you. Okay, this should work just as we are, but I'm going to switch the color contrast again because this next part looks a little bit better when it's darker. So on your right hand, if you hold that out in front of you, there is, this is your debugger control. So there's a button on the very top that says execute. You can go ahead and push that for me, please. Excellent. And I got a whoa. That's good. But just wait until you see what's next. Okay, so you see there's a blue line on the floor here. And sorry, I apologize, I'm blocking some of y'all back there, I just realized. Blue line is connecting from where this program is started to basically the entry point of the program. In Java, it's the public static void main. That's the part that the JVM actually looks for to actually enter the program. So what we're going to do here is we're actually going to watch this program execute, and we're going to see what's called the object model get built. So there's a couple more buttons on your touchpad, Connor. You'll see as you run your thumb over them, they'll light up. These are standard debugger controls. I won't go into all of them, but I'll just direct you to the button on the right, which is our single step button. What that's going to do is it's just going to take one step. It's going to tell the JVM to just, the Java virtual machine, just to execute one line of code. So go ahead and push that button down, if you will. It's the one on the right. And actually push it a couple times, just until okay, there we go. So we just generated our first object in this program. You can go ahead and walk over towards it, and I'll guide you over there. There's a hand railing that we have to watch out for. So yeah, go ahead and you can take a look at that. You see it's the main. So the program started, we built our first object. This is going to be the object that anchors the whole program. It's really going to direct the flow of traffic for the whole system. This, by the way, is all procedurally generated. You can load any Java program into our software and it'll procedurally generate these models. So it's really allowing you to get inside the head of a developer. Go ahead and keep pushing that step forward button, please. And we're just going to see what happens. So here's another object that's created. It's called an option. And actually, there's a button in the middle of the controller, your right hand. It's what we call the auto step button. Go ahead and push that down, and it's just going to start playing this animation for you. So, and keep looking in that direction, Connor, where you see these objects. You can actually take a few steps backwards as well, and put my hand on you so you're safe. So we're going to let this run for a second. As you can see, a lot of objects are getting generated here. This is to give you an idea of the complexity of what's going on inside of any given program. There's usually a lot of things happening. We're usually only looking at a narrow slice of a program. What we want to do, though, is we want to give you the big picture and then allow you to drill down on any level of detail. So here we see a whole lot of objects getting created for this compiler. They're basically all these different modes that the compiler runs in. So when you execute code, you can actually tell the compiler to run in a variety of different modes. That's what all these objects are representing. But the point here is just that lots of complicated data is getting presented to you, and the idea here is to be able to narrow your focus down and really understand what's happening on a case-by-step basis. As you see on your right hand, you have a timeline. This is giving you a sense of how far you are into the execution of this program. So we've gone 950 some steps into this particular program. And this is going to carry on for thousands and thousands, if not millions, of animations and steps. We wrote our software to be flexible such that you can really get a handle on a very large piece of data and then jump forward and backward through time so that you can really carefully look at what you want to see. So that blue line you'll see is just jumping from object to object and method to method, just taking a variety of actions. There's code getting executed on every single step. This is really just giving you a window into how the developer or the development team organized the execution of their code. By the way, this Java compiler, it's 150,000 lines of code, but it's compiling a 6-line program. It's a Hello World program that we wrote on our desktop. So this will run for, I think, about like 10 minutes. And that's like, I'm saying there's a lot that happens underneath the hood, and sometimes it's useful to actually see that and understand it. But yeah, it's complexity in VR, and we're hoping that that's actually going to help you to understand your programs better. So we can just let that run for a bit. I'm happy to actually, at this point, start answering questions. I already see somebody has one. Oh boy, we got a lot of questions. Sir in the red shirt, please.
Yeah, it might be a stupid question, but how do you type in VR?
Well, if you can figure that one out, we'd love to talk, because there's quite a bit of a discussion about input in VR. It's actually The leap motion sensors that we're handing out, the ultimate goal would be just to be able to freely use your hands however you want, and then allow the software engineers to figure out what kind of interface you want to present. If it's a virtual keyboard or something else, writing with your hands, speaking. There's a lot of work that has to go into that to make it work. But yeah, it's a good area to get into. But yes, in front.
You can use voice or VXML.
Let's have
If we could, that'd be awesome. That'd make us more like Iron Man, Tony Stark. You know, that's kind of the long-term vision here. Oh yeah, I'm sorry. So the first question, well actually both of them were about input. I apologize. And actually we're handing out a mic now. So question, input, what's a good input for VR? And as you heard from the answer, it's an unsolved problem, which I'm not gonna, I don't really have a good answer for it. So yes, next.
When you change the code in the on the lines, will it remap everything?
Yeah, that's the idea. So in order to, like, there's a little bit of complicated math that happens there when you want to locally recompile something. It's actually why we're looking to work with more people who have expertise in compilers. That's something that we're hiring for right now. But yeah, the idea is to actually give you the freedom to make changes and then see that change and, you know, just have a flow that you're in when you're developing and along with your team. It's great when you can have 2 or 3 people in the environment with you, all working on the same piece of software. Okay, how are we gonna, oh yeah, the mic's just getting passed around. Go ahead, yeah,
Okay.
you next, please.
What's your path to productionalizing this?
Okay, so productionalizing. I've never heard that word before, but I assume what you mean is getting in the
market.
Yeah, getting it in the hands of customers, right? Yeah, that's a good one. So yes, that's a very important question. What we're doing right now, our strategy is actually to work with small, medium enterprises to really actually build out the tool. We're going to be having to babysit it very much with customers because it's such a new concept, and so we're going to learn a lot from that. Eventually we want to make it a consumer-facing tool, also an education tool. I'd love to get it in the hands of students. I would have loved to have something like this when I was learning object-oriented programming for the first time. I think it would have spared us all a lot of pain, hopefully. So that's part of our mission too, to spare you that pain. Next, yes, please, sir. Are you good, Connor? Are you all right?
Yeah, but
Yeah.
should I keep...
You just keep going, you're good. Just have fun. Yeah. Enjoy yourself, seriously. It's, you know, it's good. Yeah, hi, sir.
What kind of data storage are you using? Is this embedded or?
So we're doing everything, without getting into too many details, we're interfacing with Java Virtual Machine, and we're visualizing everything using the Unity engine, which is really great for displaying information in VR. It's the long-term goal would be to give you access to all the inputs, and like we'd like to be able to visualize distributed systems. I think that would be a really cool thing to do. You know, really, yeah, lots of things you could use this for. So without going into too much detail, I'd love to talk to you more about that though offline though. That'd be something that we could probably chat about. Okay, Jared has the power of who gets to get called on. Yes, sir.
How well known are the ergonomic issues with this? Like if I'm a developer using this for 8 hours a day,
Right.
I'm probably not going to be standing, but will I get tennis elbow or, I don't know.
Oh, I get it all the time, and I get that from typing. I get carpal tunnel from just developing all day long. We do want to keep that in mind. I actually think should be some health benefits to VR, hopefully. But this is actually designed to only really be at most an hour and a half experience. The idea is that you join a company or you join a project, let's say an open source project, as one example. But most likely be, you're joining a company, you're in the office the first day, you're getting trained up on the code base. You go into a room and put on the VR, and an expert in some area of the code base walks you through and gives you the mental map. It's basically the whole idea is that you want to generate a model in your mind of where everything is, and then have that as a reference point when you then do the deep dive for days and days and days and days, which, anybody who's joined a new project, like it usually takes you 4 to 6 weeks to really get on board before you actually do the meaningful output. So right now it's a limited experience. We'd like to make it a seated experience at some point. Next.
So as for, I guess, the typing and virtual reality, can leap motion, can you put it above you? You can probably train like a classifier to oh, well, See, that's your big problem right there.
Yeah, as Jared was probably saying, I don't work for Leap Motion, but and I don't know if there's somebody who could maybe better answer that question.
Well, can you interface Leap with VR?
Yeah, absolutely. Yeah, and in fact, the idea is to integrate it right into the headset. That's something that's getting worked on right now. Yeah.
Hey,
Yes, sir.
if a lot of processing is happening in the outside world, how do you navigate it?
Say that again.
If a lot of processing is happening in outside world, like shared services or web services, how do you classify
Yeah.
inside and outside?
And that was similar to the previous gentleman's question, I think, a little bit. The idea there is that we would love to be able to show you, network traffic, all kinds of. In fact, there's other projects that have done this. There was a DARPA project that was a cybersecurity visualization that used VR. I think there's so many applications you could think of to do this, and we are focusing a little bit more. But I'd be happy to talk to you more about that as an offline topic. If you're interested. Next, please.
Yeah,
Well,
I'm
please,
just
go ahead.
wondering about, so you've got objects in the VR, but then it opens up into language and programming. I'm just wondering, have you been playing with how to put that also into some sort of recognizable object, like frequent commands and be able to move with your hand a command into place and
Right.
Yeah.
Yeah. Another fun part of this job is inventing new tools. Holographic interfaces is kind of what we refer to them. It's actually a creative challenge. It's just thinking of ways of doing things that are familiar to you, maybe in some way, like opening doorknobs and looking at objects and things like that. But allow you to do things that you couldn't do otherwise, which is what VR can let you do. I realize, there is the incentive to ask questions because you are getting. No wonder there's so many questions in the room. I was wondering, y'all just want some Leap Motion controllers. Yeah. Okay. And then how are we doing on time too? Are we? Okay. Five more questions.
So,
Should I call or no? Go ahead, please.
so it might be a little bit stupid, but when the program compiles and it finishes, what happens? Do you see the hello world, let's say?
Yes. Believe it or not.
Because I
Yeah.
just started coding, that's why I'm wondering, actually it would have been perfect to use right now. But is it just say hello world, or if it's something else?
What this is showing you is everything that goes into making that hello world get compiled into some code that actually can run on the Java virtual machine. That is a lot. That's TMI. That's way too much information that you need just if you're starting out for the first time. However, I think that it is useful to use visualizations to teach you simple things like how to write your first program, and we'd love to be able to do that at some point. But yeah, our first job is just helping the poor souls that have to deal with all this many lines of code, and so that's why we're focused on the big stuff first. But we want to do that eventually. Yeah.
Hello.
Thanks. Yeah.
Do you guys support remote debugging and maybe even production? Ryan?
I was just talking to somebody actually about that last night. Somebody was offering, I figured coding with a K allows you to set up your debugging sort of like a push of a button, and they host it all on a cloud service. So that sounded really cool. And again, that's something I'd love to talk more about. That it's not something I have that much information though, or useful things or funny things to say about. But congratulations, you got a controller. Yeah.
If you were to render stuff in OpenGL on the Java VM, would it also render in the virtual world?
So that would be really cool. That would be awesome, and I wish we could do that right now. That would to take open up on that a little bit. Imagine if you could see the thing that you're trying to build. Let's say you're trying to build a VR game. That's one good example where this would be really useful. Or
a piece of an engine.
Yeah, sure. Yeah, you're inside of the engine. You're trying to figure out your shader or lighting or something. And the idea here, the way we see it, is it would be that kind of Iron Man model where you walk over to some object and you sort of pop open the hood and see the code that's inside of it. So we actually would like to get there someday. That's something that is a really exciting idea. We see that as the future of programming. There's no reason why we shouldn't be able to do that technically. It's just a long ways off.
All right, so I've totally neglected the other side of the room. So we're going to go a few more questions over. So I'm going to give it to this man here, and then I'm going to come on to the other side of the room. So feel bad. I'm like anti the other side, but I'm not. I'll be over in a second.
There's a bias here, some kind.
Yes, sir.
I was wondering, how do you scope it? So if you just wanted to see just your program instead of like the Java C.
Right.
And then do you have any plans to like create like a virtual tour framework? Or
Say that again, the last
like
last
a
part.
virtual tour, like if I wanted to just create a virtual tour for my code base.
Right, exactly, yeah. So let me address the question in reverse order. So on that one first, that's a really cool idea as well. Think about when you've worked on a team and somebody leaves the team and the sudden panic that sets in when everybody says, okay, write everything down that you know and give us your cell phone number so we can call you in the middle of the night when something breaks in your code after you leave. Wouldn't it be better if the person could record their digital presence, essentially? We can actually track all of the data that is getting generated when you're walking around the room, and you can narrate, essentially, your code. So it's almost like your digital ghost remains with your code, and which is great. It'd be great to have, even though it's a one-way conversation, it's nice to actually hear somebody talk about their code and kind of walk through it. We think that's a great way to actually preserve knowledge over time. Top of the question, we have, this does function like a debugger, so you can set breakpoints and actually jump to certain parts of the code that you want to look at, so you can narrow down the deluge. So that's how we do that. I'd be happy to talk to you more about that if you'd like to find out.
All right, other side.
Okay,
Other side.
that last one. Yeah, here we go.
2 more. 3 more.
2 more, make them count.
Do you see this working better with augmented reality than VR?
Yes. And I'm not just saying that because the Meta guys are here. But I love the idea of having Meta. By the way, they're a really great company. They're trying to take on the other guys, the Googles of the world, with their augmented reality headset. So augmented reality, for those of you who, yeah, let's give them a round of applause. Taking on Google. Somebody's got to do it. Sorry, no, I'm going to stop there. So it would be so cool to have everything that Connor's seeing, but like out here, right? So we can all see it. That definitely is the kind of idea that we're excited to pursue at some point when that becomes possible. Yeah.
So there are 2 major aspects. One is a sort of representational aspect where you get to see the geometry of the code compiling or of similar data sets. The other is the sort of random access, like search and navigation ability to find your way to the thing you're interested in, or like to drill down, as is commonly the case. Out of the geometric aspect, what are the most useful things that you've discovered, say, about the JVM?
Yeah. Great question, because I thank you for that question, because I think for the benefit of everyone in this room, if you're interested, I was talking to some folks earlier about getting involved in developing for VR and kind of what you should expect. I think the best advice I can give on that, first of all, is to follow your imaginative instinct and just think about like the most crazy, outlandish way of doing something and then mock it up somehow. And then just get it in the hands of as many people as possible. And if you're getting a lot of feedback, which is like, it's hard to use or confusing, or like if it takes a lot of explaining, then you just sideline it and try the next idea. We've done that a lot. Like there's been a lot of tweaking on our interfaces, and we still have so much more to do. But I'm always on the side, would encourage on the side of just going with the wild, imaginative idea of like, whatever, doing like exploding, somebody actually suggested this idea the other day of like when the code breaks, it like explodes. Like the whole model blows up, and then you push a button and it all comes back together. It'd be like kind of satisfying, you know what I mean? Like you feel me, right? Yeah, absolutely. So that's what I'd say to that. We're doing one more, Jared? Okay, last question, and y'all can rest your hands now. Sorry, we've been holding you up for so long. There'll be other ways that we could, Yeah.
Sorry, you actually covered some of this, but I'm kind of interested in viewing the code in this visual way. When you do kind of run into problems, you have breakpoints or asserts that are firing off. How do you think, kind of looking at the code visually, from the various cues you have and how it's connected, will help you figure out, what the problem might be?
Yeah. Step one on our development progress is to build a training tool where you can get a big picture of the code. Step two is to make a debugger, which is kind of what we're on the way to doing. What you don't see here, but what we can do is we can actually visualize multiple threads at the same time. That's something that I've never seen any other tool that can do that visually very well, and that speaks more to the power of VR. Imagine what you're seeing here. We have all these objects, and then you saw the blue line extending through it. We color code all of our threads, so we've run programs where there's, let's say, 8 threads running at the same time. You have a blue line, a red line, a yellow line, green line, and let's say, so one problem you have in multi-thread in runtime environments is, let's say, race conditions, where you might have 2 threads accessing the same field, at different times. And so in this, what that looks like in primitive, we actually have these 2 different colored lightning bolts that extend through space, and then the other one extends and reaches the same field. And that's something where that will lead you in the direction of saying, aha, there might be a race condition in this part of the code. That's something that is sort of a new thing that we've discovered how to do here. Another example would be, in addition to race conditions, like infinite loops, for instance. That's something that if there's a really tricky infinite loop that wouldn't otherwise be intuitively obvious, you're actually going to see a repeating pattern here, and your brain is actually going to be very good at spotting that. Generally, because of the halting problem, it's really hard to actually detect an infinite loop. With this, we can actually use your intelligence to actually figure these kinds of things out with pattern recognition. So, great questions, everyone, and let's give Connor a big round of applause and welcome him back to reality. Connor, can you take this from me? Thanks for being such a good sport. Come on back to reality. You're back. You've been to the other side. Tell us what did the other side look like?
It's pretty impressive. It's a little bit darker than this world. Fewer people.
Yes, it's a barren landscape of digital information. But yeah, we want to bring more people into it, so it's more fun. I would love to give anybody who asks me an individual demo. You can reach me at john@primitive.io. I'm happy to just come up to me afterwards and I can hand you a business card. I can show you the demo. It looks awesome in 3D. So thank you so much, and let's give it up to the Meta guys. Thank you.
John, someone took your laptop. It's gone. That $4,000 machine, it's out of here.
Sorry, I'm gonna go hunt them down.
Okay, no, it's actually right over here.
It's cool.
It's holding that machine. It's just like so beautiful. It's like the Ferrari of laptops. I don't know. Anyway, let's give John another round of applause. That was amazing. Thank you, John. Our next presentation tonight is going to be Tim Christie from Meta. He's going to be talking about how AR is going to change and forever change data visualization. So let's give a big round of applause while he gets set up, and let's give him a big hand. I've got a lot more leap motion controls for people in the audience, so keep the questions coming. Not yet, though. All right, let's do it. Cool.
Hi, good day, everyone. My name is Tim Christie. I'm the data analyst on the analytics and neuroscience team at Meta. For those that don't know, just firstly, who here knows about augmented reality? Who's heard of it? That's good. Who's heard of Meta? Okay, good. Well, for those of you that don't know, firstly, augmented reality is similar in style to virtual reality, but instead of putting everyone into their own virtual worlds, we're trying to overlay digital content on a real-world environment. Meta itself is an augmented reality headset company. We're building an augmented reality headset that uses both this concept and also principles in neuroscience and vision science to create the most natural interface possible with our computers. So, I guess I've done the plug. Today I'll be talking about how AR will affect data visualization. This is a really interesting topic to me because I assume like a lot of you guys, I make a lot of charts and a lot of data products for work. And I guess unlike a lot of you guys, I also spend a lot of time in augmented reality glasses on a near daily basis. The more I hang out in this augmented reality space, the more I realize our existing tools are leave a little bit to be desired. And I guess it's not a perfectly interesting topic if I'm the only one that's interested in it. Turns out our customers really are as well. We did a little survey, everyone that purchased our product, asked them, what are you going to use this for? And second most interesting topic to them that they're developing applications for is data visualization. Over 35% of people are really interested in this space, of everyone that's bought glasses from us. Second to the very general, very broad office productivity category. So I guess, what are the limitations of our current tools? I can really boil this down into two main categories. First one is the scale of the data that we can present, and secondly is how it deals with 3D objects. Firstly, the limitations of our current tools, like the chart I showed you before. It's with 4 or 5 variables. It's quite easy for us to tell a story. But as soon as we get a really deep, interesting data set like you guys have, I'm sure every data scientist here has an amazing 20,000 plus point data set that they just really want to visualize. We start to get limited. And to really tell a story with this data set, we have to make some compromises. So sometimes we drill down and force our users to click through and click through and click through layer upon layer upon layer of data. And it really starts to overload the working memory, and we want to know, the user has to remember where in the stack they are in comparison to the whole data set. Another option we can use, we can sort of crop the data set and make them move it around, but still they have to keep this holistic view of the data in their working memory. The other limitation is dealing with 3D. Naturally, if we're using traditional 2D tools such as paper, presentation, like projectors, general computer screens, we're representing a 3D object on a 2D plane. Now, the human brain is pretty damn clever. We can use a lot of different kinds of depth cues to pretend to see 3D, but we can't really truly do it. So of this, for example, you can tell that the orange square is behind the blue square. We can tell that, but these are hacks, workarounds to really perceiving 3D data. Another example is we can tell if we assume that both of these squares are the same size. We know these squares are the same size. The smaller one's probably further away. But this isn't every depth cue that we get. So what improvements does AR provide? There's plenty, but for the purpose of brevity, I'll talk about 3. Firstly, the ubiquity of information, the scale and direct manipulation of our data, and finally, we get a full set of 3D depth cues. So I mentioned earlier that our data products have been around for a really long time. These charts have been around for centuries. Bar charts, line charts, scatter plots. It feels like if something's been around for 300 years, we've probably hit close to a peak in how good it really can be. Turns out that's maybe not the case. This is really a low-hanging fruit for AR. We can just take these same data sets, and as soon as we just put them in a new context, straight in front of someone, it's actually quite a useful use case. So what we can do is, we can view relevant data at a glance, and this is particularly useful for time-sensitive tasks. So instead of having to constantly look at a data product while we're trying to work on something that, for example, in an operating theater, we have, so this is really particularly useful for time-sensitive tasks. One example of this is, who remembers the Google Glass? So didn't really achieve a mainstream success. It was a really cool AR product just before its time, but it found these really cool use cases in certain verticals. So one of these, we had a trial. There was a trial at Princess Margaret Hospital in Perth, back in Australia, where all they did is they got the patients' vital signs, just their heart rate, their oxygen levels, those kind of things, and just place them in the glasses, and that was it. And what they found was just the simple fact of having the important contextual information in their own line of sight, as opposed to constantly having to look back at a old-fashioned machine. That was enough. That was a use case that was really important to them. So yeah, 75% of these guys were comfortable using just this trial in an operating theater, and 76% would just use it again. They were really happy with the whole process. I think we could do more than that though. So another improvement, and a little more exciting, and it's actually a little closer to the VR demo that we had from John, by the way, which is actually really cool. An improvement that AR provides, we can start to navigate through the data a little more naturally. So when I said before, we have to drill down, we have to crop things, we have to create abstractions to be able to view a complete data set. By having it completely around us, this reduces the abstractions. It also reduces the cognitive load of said data set. Finally, the final improvement that I want to talk about that AR provides with data visualization is it provides us a full set of 3D depth cues. So I talked before about our little workarounds. The human mind is very good at playing tricks on people and perceiving 3D when there isn't 3D to be perceived. But when we have true AR, we can get the full set of 3D depth cues. So I want to quickly talk about. We've got stereo vision, so just having a different image in your left eye and right eye, that's enough to get some really nice depth. We can also have, if we have sensors on our AR devices, we can also get real-world occlusion. And this is really cool because we know we can perceive depth of true objects, and if we have the sensors knowing where a true object is, and we place some particular data point behind that object, we can perceive a relative depth compared to something in the real world, which is really cool, a really cool idea. And finally, this one is actually really impressive, interesting, to me. The concept of proprioception. When I was practicing this talk earlier, I really struggled to explain this properly, so I'm going to get you guys to help me out here. We've got a little experiment, a little test. So if everyone can close their eyes really quickly, just take your hand out and just touch your nose with it. Alright, great. And if you just sort of put your hand out in front and just touch your hands together. Okay, great. So, I guess you're thinking, like, why did... you can take your hands down. That's fine. That's it. I guess you're thinking, like, why did Tim make a room silently high-five itself? This is a really interesting topic. So the human body perceives depth at different levels, in different ways. So if you're looking at the end of the room, you can perceive depth, but you can only use vision as that concept. When you start to bring data within your own personal space, within your own arm's reach, you perceive depth at a much more precise level. So to go back to my little crowd interaction, the ability to touch your hands together while you're in while your eyes are closed, you're not using vision, you're using just your body's sense of self to perceive depth. Okay, so these are three kind of interesting use cases, three interesting improvements, but let's do a hypothetical use case. So this is how we currently view brain scans in operating theaters. So what we want to do is use these three principles that I've just talked about, and how do we make this better? So firstly, instead of placing it on a wall, we could just place it in our field of view. Keep the same data set, just place it in our field of view. So if you're operating, if you need contextual information straight away, yeah, sure. You can have this here instead of over here. We can do that. We can do this a little better. Maybe we increase the scale because we've got a theoretically infinite field of view, so we can view each part of the brain at a much deeper level. And finally, using a full set of 3D depth cues, we don't have to abstract away all these slices. These are slices of the brain. So we don't have to abstract that away. We can just place a real, and this didn't actually come up as well on the projector as it does look here. But this is a brain. This is shot through the Meta 2 glasses. This is an actual brain model that you can see in front of you, and if you come to our office, you can demo it and grab it and throw it around. So that's all well and good. Like I could talk about theoretical depth cues and what we can do, what we can do soon. But you guys are very analytical people. You want to see real data now. So very recently we did a paper. And I'm going to just read this out. So we did a paper at the IEEE ISMA conference, and for those that don't know, the IEEE ISMA conference is the International Symposium on Mixed and Augmented Reality, and that's the largest AR/MR conference in the world. We presented a paper where we explored the idea of using AR to view 3D information and as an instruction set. So what we wanted to do is see if our augmented reality glasses could be more useful than traditional information sets for any 3D oriented task. So for those that can't read it, the paper title is Exploring Immersive AR Instructions for Procedural Tasks, the Role of Depth, Motion, and Volumetric Representations. It's a bit of a mouthful. So how do we do this? We had a little experiment at the Beta Breakers Expo earlier this year here in San Francisco, where we got 77 participants to just build a Lego set. The variables that we had in this experiment were the instruction sets that we used. So the control, was the original Lego instruction set. Secondly, we had what I will call from now on a static 3D instruction set, where simply we got a 3D representation of the lighthouse in the glasses in our Meta 2 prototype, with the next and previous button that you can see here. You could tap next and previous, like flipping a page, and it would just show you the next Lego piece to go onto the lighthouse. The third one we used, the third variable, was what I will now call dynamic 3D, which is exactly the same, except we added the depth cue of rotation. So in theory, this is a deeper, more true AR. So our hypothesis was the paper would be the slowest, the static 2D with a couple of 3D depth cues, more than the paper instructions, would be the second fastest, and the fastest would be the one with the most 3D depth cues. We also wanted to see how people perceived AR as an instruction set, because it's not worth it to just know that something's faster. People want to feel like it's faster to them as well. You can see a lot of websites that things animate slowly, but they feel faster if there's something happening. So what we found, we surveyed all the AR participants, and 86% of them found that the AR was more interesting. More effective. It was more effective than the paper instructions that they'd used previously. That's okay, but we want some quantitative data. So we measured each step time, and again, didn't throw up that well. We measured each step time of each step time of the Lego building process. And we adjusted for the mean time because each step ended up being slightly different. There was tiny little fiddly pieces and there was big, easy to place pieces. What we found here, it's a lot of error bars that you can't really see. Statistically significant Dynamic 3D was faster than paper. What was really interesting to us was static 3D, by only having a couple of depth cues, was actually slower than the paper. And more simple approach, more projector friendly, is that we found, yeah, paper on average, if we took the mean of the whole process, took about 4 minutes to build the Lego model. Static 3D took right about 5 minutes to build the Lego model, and dynamic 3D took 3.5 minutes to build the Lego model. And this actually, so this was different to our hypothesis, but our literature review, we did a lot of reading about this earlier, and basically what our literature review summed up as was basically 3D tasks can be done quicker with 3D representations of the objects if you do them right. That's all the literature, you know, that we were reading came out with. It was very hot and cold on which was actually better, and that's really what we found. We did a intentionally poor-ish job of representing a 3D model, and we did a good job. The good job was better than the traditional models and of presenting data, and the poor-ish job was worse. So the key takeaways of this, I hope you guys really take something away from this. The 2D media limitations of presenting data. We've got scale, so we've got a hard limit on the amount of data that we can put on any given screen. The direct manipulation, we've abstracted away a lot of we have to abstract away a lot of the interactions with the data, and viewing 3D objects on a 2D plane is tricky. Our advantages of AR is we can view this data anywhere. We've got a full set of 3D depth cues now, and we get more natural interactions with our data. So, thank you. Just got to plug the blog post as per the marketing people's request. We've got a blog post about this coming out on Friday if you want to read it. And any questions that don't get answered here, I don't really do Twitter, but if you want to email me, I'll answer that straight away. Thank you.
All right, here we go.
Thank you, that was very enlightening. So the 3D is great, right? But let's say I have a data set with 20 dimensions, and there are now tools for the desktop which allow you to like slice and dice it. But I'm really excited what you can do using the tools you mentioned, like the depth cues, like maybe some of the dynamic movement of the model or something. That you could like show me those dimensions, like let me explore a very complex data set, which is like is not easily represented in 3D. I would love that.
Yes, so I guess one of the things I found really interesting, sort of pursuing this topic, is I'm not totally convinced that just adding one extra dimension, so going from cool 2D scatter plots to well-represented 3D scatter plots, or for example, is the final end goal, right? I really like the idea of just having like really long, extended, like imagine your time series data, like a really long, complex, like, I'm not answering you.
Well, some data sets are inherently multidimensional.
Yeah.
And like, we as humans have really, really hard times with this, right? So I wonder if this technology will help us.
Yeah, so I mean, I think it will, but I think it would take. I don't have the answers there. If I had the answers to that question, I'd be a billionaire. So I think we can get closer by adding an extra dimension, and this is actually a really interesting topic. Like how many dimensions can we add before we start to lose, any sort of understanding? I'd love to talk to you more about that. That's actually quite interesting.
In the Lego example that you showed for your research study, what were the issues with the depth cues and the static 3D representation that made it slower than the paper representation?
This is something that was actually really interesting to us, because we actually only added one extra depth cue. That's all we did. We only added the concept of rotation. So motion is a depth cue by bringing certain objects closer. You know the relative distance from where it moved from. That's all we added. I think there might have been some kind of aspect of people have were not familiar with the product of AR in the first place, and just the actual action of like pressing right on a keyboard versus pressing next on that I think might have been where I hypothesized where that delay came in. So I guess when people start to use these sort of products more and get more used to them, the flat representations would level themselves out, and then, I mean, I hypothesize again that adding more depth cues will reduce that time even further.
Howdy. I don't know your background, but I thought you said you might be an analyst, or you've looked at data visualization tools before, or you at least showed us some charts. So I'm just really curious, what have you seen as helpful visual representations in 3D that are as analogous or as useful as a scatter plot, or like the charts that you were showing? Is there something that you've learned really works well in AR? And are there any tools that you guys have come across, like in 2D space? A tool like Tableau is what people would use, or D3. But so what is sort of that analogous tool, if that exists yet?
Yeah, so I guess this is a really new space, and this is a topic that hasn't really been totally fleshed out. That's kind of why I did the topic. It was an exploratory thing for myself as much as I hope everyone else. I think there's always going to be a place for your scatter plots and bar charts, because so much time we just want to compare X variable against Y variable, right? So the 3D representations of that, I can't say yet. I really like the idea. I was talking about this one Friday afternoon after work. I was telling with the guy, like, we were having this exact same conversation. We were like, what would be the killer visualization?
What are those 35% of your clients that are doing VR or data viz with the tool that are doing?
Yeah, so I mean, I haven't actually gone through and physically interviewed everyone, and that's actually probably a good thing to do next week. Yeah, so a lot of these guys, like, they have their own verticals, and they're actually just, visualizing like an actual object, like say, for example, like a car, and doing wind flow over that, instead of having to actually physically build a model, put it in a wind tunnel, etc., etc. I think one of the biggest use cases for data viz is this ability to rapid prototype now. Like, we don't have to wait for a 3D model to print. We don't have to do this. We just place it and view it with the same dexterity that a physical model would provide.
I have a question about occlusion on there.
Yes.
You mentioned that as one of the things, and that's kind of like one of the big things that a lot of people are trying to solve. Have you found, are there like best practices or things? Because obviously with VR hit, there's things that you don't do to keep people from getting sick. When 3D TVs hit, if you break the edge of the screen, it breaks down the immersion. Do you find some of these findings you have, if you're doing occlusion but it doesn't quite hold up, does it affect people in a way that there are best practices around that?
So I haven't found that issue with like the occlusion of hands or anything. The one that I've discovered is if you make a gesture like almost too natural, someone just loses the concept of having sensors in front of them, right? So they see this object and it just grabs, it's occluded, it's just, and they grab it and they just try and put it behind themselves, and that's when it starts to break down. When you start to lose things by just like breaking the bounds of the hardware.
Hi. Sorry. Before even getting into data visualization, do you think there's a good application just for looking at data itself, for example, in SQL, looking at the relational databases from the relation between table and table, or like even like vector representation? Imagine like a 3D representation of that would really help data scientists to visualize how data is related.
This is something I've really been thinking about as well, because through my days at work, I write a lot of R, And a lot of this stuff, it's not this like crazy, putting models upon models and all this machine learning stuff. A lot of it's just slicing things up in certain ways. And I've really started to have this same kind of thought of, the visualization part of any sort of data analyst pipeline is it's the sexy 20%, right? And the rest of the time, the 80%, that's where the real meat and bones is. So that would be something that would be really cool, and I think would be very valuable, is getting a lot of the common verbs of like your SQL or certain R packages, where you select by this, group by this, and manage to have that in an AR space and visually do it. I think for a significant percentage of people, that would be much more useful than having to type out those commands themselves. So it's going to be the power users that have just hit a hard limit. But I think that could be a really interesting proposition. Yes?
It seems to me like one of the big problems with AR and VR is acclimating new users to it, right? You were talking about power users, they get used to it. Yourself, you're used to it, and so you know how to control and interact with the world. But going back to your experiment and the data that you collected on how long it took people to step through, did you guys have any acclimation period for people to get used to it so they weren't fumbling with the controls or geeking out at how cool it was and just were able to kind of move along through it?
We did have like a little 1 minute geek out period. So basically we just threw up we did it was a Unity scene, right? So we just had like a bunch of primitives, like there was a cylinder here and a cube here, and just like slapped them around.
It seems like the numbers were kind of higher than you would expect, because 3D is intuitive to people to work with. So I would expect over time for those numbers to come down.
Yeah. I'd hypothesize I'd agree with that statement. I guess I'm inherently biased though, because that's what I'm working on. But yeah, I do agree with that. There was a lot of, after each tester came out, like there was a lot of just like, oh my god, that was the best thing I've ever done, and it's like, okay, like this is actually just a research study for us. But to even just the idea of having the glasses on, just pressing a virtual button was like a mind-blowing new experience for a lot of people there. So,
you mentioned early on about how you can kind of lessen the cognitive workload by putting things into 3 dimensions. Have you found there to be kind of an almost overloading of information point where suddenly I see too much information, or I have so much around me that I end up having to do kind of more work in my head to kind of filter out things? Or do you find that it's a pretty smooth transition that makes it easier the more information you're able to be exposed to?
I mean, I don't have like a definitive answer to this, but I imagine there will be a point where you hit, no matter what way you try to present a certain data set, like it will just be too much. I just think that AR and using your visual surrounds and getting context that way, that sort of starts to increase that limit of when you hit that theoretical overload bound. And I mean that's going to be different for many different people. So that's actually a very interesting and open-ended question. Thank you.
Also kind of related to that question, did you ever consider filtering out stuff with AR? Because basically you could, I don't know, very stupid simple application could be kind of an ad blocker in the real world, but just in order to focus on certain tasks.
So I guess from like a data viz perspective, an ad blocker on the real world, that's a big moral AR question that I'm not going to start to get into. That's a big I guess controversy between different parties. But I guess from a data viz perspective, let's zoom in a little bit. Have you ever used like any data viz tools that let you like select outliers and stuff? You know, the ones where you like click the scatter plots. I guess one of those, like getting a mouse and just clicking a single point is just a pain. Like maybe I'm just uncoordinated, but it's really hard. And I guess from a 3D data viz in AR perspective, like the ability to just reach out and that's an outlier, that's an outlier, that's an outlier. I imagine that would be a lot quicker for a lot of people as well.
I actually have 2 questions.
The first one being that, have you guys played around with streaming data in the sense of like getting real-time data being piped into this? So like I'm a physicist by training, and very often we have like tons of data which is very often like moving in time. And I wonder if you guys have played around with that. The second question is actually related to something somebody else asked in the past, which was visualizing the raw data just to be able to understand the structure better. And I think there's probably a lot of potential here where you could relate this to the talk before this in terms of being able to like do pivot tables, just like simple aggregations as you were mentioning, like sort of in real time to be able to like understand certain sections of the data. I'd love to hear about that.
Okay, so the first part of the question, the streaming data, that's really interesting to me. Unfortunately, I don't have like a nice definitive answer. I haven't done it yet, but it is, that is something quite interesting to me, and I'd really like to chat with you about what your ideas on that are after. The other part with the visualizing information, this is something, when I watched the first talk, actually, that was, I sort of had the same thought fire in my head of just like, imagine like, for me, my code, it's all snippets, right? But my databases are a little more complex and more on that kind of scale. So imagine, having a relational database with all your tables here, and your primary key from here to here, primary key. Yeah, that's actually something that would be really interesting. And then if you do your SQL query and just go, select X from here and then this column lights up, this column lights up, this column lights up. That would be a very interesting use case, and I guess sort of agnostic between AR and VR. That would be useful in both dimensions. Who's got the mic?
So I remember you said you wanted to take on like the big guys like Google and Microsoft. So what do you think about Magic Leap, and are you guys like similar to them? Are you guys a little bit different? Are you taking it the more data analytics approach, or are you trying to do like AR in general?
I guess like you guys, I know nothing about Magic Leap, so I can't really like go into much detail because I don't, they're naturally very secretive, so I can't compare our company to theirs.
So what's your pitch then against the people like Google?
So I guess our pitch is, we're really trying to make a more natural interface to AR. Just sort of like starting without any baggage, going like, how would I want to interact with a computer, and how can we build it? That's really boils down to how we feel about augmented reality. Jared, do you want to bring the mic down the front? Because two very patient people.
These are my friends from the meetup from last night. Hey guys.
Hey. Did you want to go first?
You go first.
So I'm a biohacker, and you've probably heard of measuring and self-tracking and stuff. Is there a way? Because you were looking at, you mentioned something about you could just look at the data outliers, right? So in terms of, say, if I get a comprehensive metabolic panel, I get all these different data readings, right? And I do this every 6 months or every year, and I track everything from sleep to orgasms to, literally my food intake, if I go outside of my food intake. So I want to be able to track just for the fun of it, because I think it's really cool to be able to know what's up and how you can improve and stuff like that. Is there a way to use some of the data you showed us today to kind of track these outliers, and if there's data points that are different over time, and to basically become better as humans, human body basically?
Okay, so that's a really interesting point. Like I guess you're sort of saying the idea of having almost like a stat space, like a HMD nearly, that's actually really cool. And the thing with outliers that I find interesting, like if you just have everything just ticking along, you'll start to get a lot of information fatigue. Like you see this happen with certain types of dashboards. You just see the same-ish looking data all the time, and then you start to miss spikes. So I think having like an alert-based kind of system in that sort of regard would be much more useful than actually physically measuring every single stat. Just like, wait, once this hits a threshold of, once my heart rate is too high or once my heart rate is too low, then show it in an augmented reality
Yeah,
fashion.
or one of the other concerns is, say for example, sometimes total cholesterol going up is not necessarily bad if your HDL, which is the good cholesterol, is going up, and the LDL, which is the bad cholesterol, is going down. Or say, for example, you have certain vitamins that kind of work together, like the fat-soluble ones or water-soluble. So sometimes if you could relate certain pieces of data and say if there's something off, or something that, oh, we got to check for that, to be able to know how to use this type of technology to what otherwise would take a doctor or someone to go through all this detail and expense, then to just, oh, we have this, here's my blood info, and what can I do before I, go to a doctor?
So I guess if you've got this kind of stuff is way outside of way beyond my knowledge, I guess. If you can just set up any sort of trigger, I guess, if you know these relationships, I think AR's the key takeaway for this for you would be, yes, you can trigger these near instantly in your field of view, as opposed to having to wait for a doctor's appointment or wait for this or wait for that and crunch the numbers yourself. If you have that data running, yes, you can place it here and that would be a nicer trigger for you.
Hey Tim, fellow Tim here. My question is, well, I mean, I'm always trying to arrange my data, and I've tried every like mind map and Trello and everything, and I just can't quite have enough screens or enough post-it notes or something to organize my data. One thing I'm always wondering about is I've seen actually the videos of Meta, the glasses and stuff, and I'm like, oh man, that'd be really great for coding. I've seen videos of you guys having like screens everywhere around you, and that's pretty cool. Main thing I'm always wondering about is manipulating that data. Have you guys? I've tried a HoloLens where you get tired after a while of pinching things and stuff. Your arm actually gets tired. I'm wondering if you guys have actually worked with anybody with like haptic gloves or any sort of where you can get different types of feedback in your hands. Just something more than just trying to pinch away. And I know that you guys have done so much with like the optical recognition, or that you're using infrared, or I'm not quite sure exactly what you're doing there, but it seems like you're able to grab the objects pretty naturally and move them around and such. But have you guys done anything with like haptic gloves or anything, next step?
Yeah, so we're trying to avoid having a lot of accessories. We want to go from the inside out. That's really, so having one headset that does everything, and what we can do now, we can track hands. Obviously we can't give you haptic feedback, but you can get these sort of gestures. I think in your use case, like just the ability to grab, move, and select by touching and grabbing, that's I think enough. I don't know how many of you guys have used it. Have used any AR with real hand gestures. This is a little like pseudoscience-y, but when I use them, like there is an element of touch. Like it is hard to describe when you hit something and it moves. It's not true haptics. It's not anything actually, but you do get some kind of feedback that hey, I interacted with something in the real world. So maybe not haptics just yet.
I mean, I don't have my...
All right, we're going to do 2 more questions. Okay?
I'll talk to you later.
Okay. Hi. My question is, your MetaVision MetaVision is selling the AR glasses, right? Are you selling a program, an environment, and how much setup do you need to do to get data in? Is this an API that is just, you have to program in your data flows or whatever into the system, or is it something higher level?
Okay, so this is coming out with a developer kit, and we'll come out with, so you get the kit, you plug it in, you've got your SDK, you've got your APIs. We give some example scenes, an operating environment to work with. At this point, no true dedicated data visualization tool, but we give you all the tools to build your own. And we have a lot of it, like I said before, we have a lot of developers working on, a lot of customers working on a data visualization tool, and one of those may be open sourced or for sale in the future. Yeah, actually, a pet project of mine that I really want to work on is implementing R in the glasses, but that's a little down the road, and hopefully someone with a bit more Unity chops than me does it first.
Hi. So I'm not too familiar with the data you get from this, but I was wondering if there's any work with sign language. So, for instance, doing translation directly from someone speaking in sign language to text or even to speech and vice versa.
Actually, so that's actually a really, really interesting use case. Currently, we're not working on anything like that, but I'm sure someone somewhere is. You've just had this idea now. Like I
or
think.
You can train like even robot hands from the motions of the data you get from a hand.
So I think, yeah, like I said, this isn't a use case that we've explored or built yet, but definitely possible, and probably possible with the current setup that we have. If you can view hands, we can view hands. We can do it.
All right, that about wraps it up for questions. Let's give Tim a round of applause one more time. You don't do the Twitter thing, but we can email you if we have questions.
Yeah, you can tweet at Meta Glasses. That's our company one, and someone will respond there. Or email me at tdchristie@metavision.com, and I'll definitely respond from there.
Is there anything else you want to share? Any like big announcements coming up that Meta's unveiling, or anything you want to before we go?
No, I'd just like to say thanks to everyone for showing up, and of course to Galvanize, and also John beforehand coming in at a couple of hours' notice. That was awesome, especially doing a live demo. He seems to be an old hat out of bed. Like that's still terrifying every time.
That was his third one this week. So, all right, everybody, thank you for being here. Give yourselves a round of applause, and thanks again. Any questions about the SF Data Science Meetup? If you'd like to get involved, volunteer, be more a part of it, just email me at jared@galvanize.com. And if you want to get involved with Embrace VR, which is the other meetup that we're working on, feel free to email me again at jared@galvanize.com, JARED@galvanize.com. Thanks again, everybody. Have a great night. And you're welcome to hang out for a little bit more. Doors don't close until 9, so if you want to talk with people, feel free. Thanks. Bye.
Super.